So the first thing is for you to convert these equations into matrices. So our main matrix will be the coefficients of this part. Then we will have a column matrix, which will be the result. If I will be associate that in circuits, usually this XYZs are currents. Let's say current 1, current 2, current 3. Then these are the voltages. If in case you have equations that are interchanged, you have to reevaluate the equation, summing up all the same variables. Then kapag wala yung variable na yun, ibig sabihin 0 yun. So the main matrix of this will be 4, 6, and 9, 6, 1, and negative 2, then 5, negative 8, then 1. Then you will have a column matrix, let's say E, 6, 20, then 10. So this will be the column for X, column of Y, column for Z. So all the coefficients should be in the correct column. Cramer's rule is we just need to have the determinants of the main matrix, and after getting the determinants of the main matrix, you will change the column of that unknown variable by the column matrix. So let's say we have to find the determinants of matrix A. So what is the determinants of matrix A? While you're solving for the determinants of A, as you can see what I did, for us to find the variable X, I made a new matrix where I replaced the column of the unknown by the value of the column matrix. I omit the column X, change it by the column matrix. Then, after that, you need to perform the determinants of this new matrix, then divide it by the determinants of the A. So yes, determinants of A is negative 633. So that means you will divide the solved determinants X ng negative 633. So what's the value of the new matrix? You will divide it by 633. So while you're solving that, as you can see, I'm writing the solution for finding letter Y. So we will omit the values of the column ng Y. We will replace it by the value on the column matrix. So our X is, yes, it is 2.9668. So what's the value of the numerator? It will be negative . Yes, negative 1860. What's the answer for the determinants of the Y? For letter Z, 465, the X, 61, negative 8 for the Y. Then replacing the column Z by the column matrix 620 and 10. Then ganun din, this will be divided by negative 633. Then this will be negative 633 with the value. Y is negative 296 or 0.4676. So what's the value of Z? Z is yes, negative, and that is 602 divided by negative 633, and that is negative 0.95. So that is how we use the Cramer's rule. Another example, if we have x plus y plus z equal to 2, then 3x minus y plus 2z equal to 4, then 5x minus 2y plus 3z equal to negative 7. If that is Cramer's rule, we have to get first the main matrix. So that will be 1, 1, 1, then 3, negative 1, 2, 5, negative 2, then 3. And let's say E. Or the column matrix is 2, 4, negative 7. So what is the determinants of A? And our x will be divide determinants A. Re-replace natin yung x by the column matrix 2, 4, negative 7, then 1, negative 1, negative 2, then 1, 2, and 2. So while you're solving that, I am arranging then our y. So the first column is from x, then the second column is being replaced by column matrix, then the z pa rin. Then kapag z na ulit yan, so that is divided by determinants A. Then 1, 3, and 5. Then that will be 1, negative 1, negative 2. Then replace our z by 2, 4, and negative 7. It is best to use the Cramer's rule if you only need a certain variable. Let's say you only need variable x. You don't need the variable y and z. So it is easier to solve the problem using Cramer's rule other than the Gaussian Elimination and Gauss-Jordan. So 1, yes. So it will be divided by 1. Then what is the determinants of x? The value of x is negative 39. Then our y, yes, it is negative 13. And z is 50. Checking naman, di ba, x plus y plus z is equal to 2. So if x is negative 39, then y is negative 13, and z is 54. Is it equal to 2? How do we do Gaussian elimination? So in Gaussian elimination, our target is for you to have this form where you're going to use augmented matrix. That means, just like earlier, you have 3 equations, 3 unknowns. Then, hindi na siya katulad ng Cramer's rule na meron tayong main matrix and column matrix. It will be an augmented matrix. And our target is to have puros 1, yung iyong main diagonal, but meron kang values above it, resulting to ganyan. So, the asterisk means the values of these elements will change upon the process of performing the Gaussian elimination. So, let's get the matrix from the last example. So, the first step in using Gaussian elimination, you have to check the first element of the main matrix. Kailangan yung element natin na 1, 1 should have the value 1. Luckily, itong example na to is yung 1, 1 natin is already having the value of 1. So, if hindi, you have the choice to interchange the equations where will give you 1 as the main or the first entry of your matrix. Or, you can divide the entire row with the reciprocal of that first element for you to have 1 on the beginning of the matrix. Okay? So, dito, it is 1 na. So, we don't need to interchange or divide the first row. So, then, we go to the next step. And that next step is to zero all the numbers or all the elements below that first entry. So, alin yan? you have to zero this element. And how? You have to multiply 3 for R1 minus R2, okay, and 5 R1 minus R3. Then, after that, copy 1, 1, 1, 2. So, 3 times 1 is 3 minus 3 is 0. 3 times 1 is 3 minus negative 1 is 4. Then, 3 times 1 minus 2 is 1. Then 3 times 2 is 6 minus 4 is 2. So, siniro nyo to, then also perform that operation on all the elements on the same row. Next will be naman 5. So, 5 times 1 is 5 minus in row 3. So, that is minus 5 is 0. Then, 5 times 1 is 5 minus negative 2 is 7. Then, 5 times 1 is 5 minus 3 is 2. Then, 5 times 2 is 10 minus negative 7 is 17. Okay? So, this is the new matrix after performing these operations. Okay? After performing this, and you zero all the elements below element 1, 1, our target is to have this as our diagonal. That means you have to make this element value of 1. And you can change that, or you can make this element value of 1 by multiplying it to its reciprocal. So that means you have to multiply second row by the reciprocal of the element 2, 2, and that is 1 over 4 R2. Will give you, copy nyo yung first row, then 0, 4 times 1/4 is 1. 1 times 1/4 is 1/4. Then 2 times 1/4 is 1/2. Okay? Then after that, check our pattern. We need to zero this. And that is, you need to multiply 7 R2 minus R3. Pwede din if you want negative 7 plus R3. So if we go on negative 7 R2 plus R3, 1, 1, 1, 2, then you have 0, 1, 1/4, 1/2, 0. So negative 7 times 1 is negative 7 plus 7 is 0. Negative 7 times 1/4 is negative 7 over 4 plus 2 is equal to, and negative 7 times 1/2 plus 17 is what value? The answer is, yes, it's 1/4. Then, while you're solving for the last element, the next step will be, as you can see, it is nearly on the same pattern ng ating pina-follow. So, the last thing is you have to multiply the element 3, 3 to its reciprocal. So, mangyayari dyan, 4 R3 ang last step on this matrix. So, we'll give you 1, 1, 1, 2, 0, 1, 1/4, 1/2, 0, 0, 1. What's the value of this last missing element? 27 over 2. Multiply it by 4 will give you 54, which is the value of your Z from the Cramer's rule. So after this, we already have this pattern. In your solution, how do we find the other unknown variables? So that means after the Gaussian elimination, you have to perform the substitution method, where therefore Z is 54 based on the matrix. Next, go up. The equation is, so substitute the value of Z to Y plus 1/4 Z equal to 1/2. Di ba ito yan? Ayan. So that's the difference from you are going to use them on the actual given formulas. Hindi. Doon sa what you get from performing the Gaussian elimination. So, after this, so y plus 1/4 of 54 equals to 1/2. So, what's the value of y? Then, after getting the values of the x and the y, you will substitute it on the first equation or the values from the first row, which is 1, 1, 1, 2, which is x plus y plus z equal to 2. It should be x plus the value of the y plus 54 equal to 2. A negative 13, then ito, gamitin niyo siya sa negative 13 dito. So, your x is equal to negative 39. So, yun yung difference of Cramer's rule and Gaussian elimination. Cramer's rule, all of it will be determinants. Then, replacing the variable that you are solving by the column matrix. In Gaussian elimination, you have to perform all the process on each and every elements of that augmented matrix. Then, after having your main diagonal with the value of 1, you will perform the substitution method na. Now, how do we do the Gauss-Jordan? Gauss-Jordan elimination is that all other elements outside the main diagonal should be 0. Or you have to have identity matrix on your main matrix. So that is the pattern here in Gauss-Jordan elimination is identity matrix, then asterisk na yung sagot. So that means whatever value that you get on this part will be equivalent to variables. Diba? Ito yung x, this is your variable y, and this is your variable z. So that means the starting hanggang certain portion will be the same with the Gaussian elimination, and that is on this part. Okay? The process of solving Gauss-Jordan elimination is the same on Gaussian elimination until this part. Medyo may similarities na sila hanggang dito. Why? So remember, on this part, the next aim is to zero this portion. Nakalimutan, i-zero nyo lang din yung nasa taas. So you will add another step here that you will solve simultaneously by zeroing or making your element 3 to 0 and making your element 1 to 0. After that, magre-result siya. So, simultaneously, isosolve nyo yan, then iwa-1 nyo to, then isi-zero nyo siya, resulting to the values of x, y, and z. How is that? So, we will copy this portion. So, dalhin na natin siya dyan. Then, of course, pwede natin din isama that for row 1, it will be R2 minus R1. Okay? So, to follow that, our next matrix, so 1, 0, 0, ito 1, 1/4, and this one will be 1/2. We all know that negative 7 R2 plus R3 is 0. Then, nasolve na din natin to kanina. This is 1/4, and this is 27 over 2. Isa-solve naman natin yung nasa taas. That is R2 minus R1. That is 1 minus 1 is 0. Then 1/4 minus 1 is negative 3/4. Tama ba? Then 1/2 minus 2 is negative 3/2. So yes, pwede po tayo magkaroon ng negative value in our matrices during the operation. Then after that, we need to make the element 3 as 1 for R3. So this one is 1, 0, 0. Then since 0, 1, 0 na to, hindi na natin yan mababago. Then, and this will turn 1, So, ito ay negative 3/4, 1/4, then negative 3/2, then 1/2. Then the answer here is 54. How will you make these two elements 0 na? So that is by performing or multiplying negative 1/4 R3 plus R2. If in case na hindi siya mag-negative, let's say ang naging sagot is positive 13. So you can just inverse or reverse the sign. Pwede mong gawin 1/4 over R3 minus R2. Pwede naman yan. Then, kasi here, you will not do anything after you have this. But on that first row naman, it will be 3/4 R3 plus R1. So, pwede din yan. So, it will give you an equation. Ito 0, 0, 1, 54. Ito 0, 1, 1, 0. Then, based on that, so that is 0. Then, our R3 is 54. And our R2 is 1/2, negative 13. Then, 3/4 R3 plus R1 will give you 0. Then, for your 54, ang R3, R1 is negative 3/2. Ito, kita niya nag-positive siya. So, babalik na rin nyo lang yan. Ito, you will change this into, so negative nito, then negative nito, will give you negative 39. In Gauss-Jordan elimination, whatever your answer here, yan na yung final answer. You will just conclude based on your matrix. X is equal to negative 39, Y is equal to negative 13, and Z is 54. No more elimination method, no more substitution method.